All right, quiz 8.3. You got some raw data, some IQs of 5th graders. Number 1, you'll be doing a confidence interval, 99%. Number 4, you'll be doing a 70% confidence interval. And the rest of the problems are related to those confidence intervals. All right, first thing you got to do when you're being asked to do a confidence interval is decide if it is proportions or means. Are they talking about percentages of 5th graders at something something, or are they talking about the averages related to these 5th graders? They want averages. They want an interval for the true population mean. So this is on means, not proportions. We're doing x bar, so you go to your formula sheet, x bar plus or minus t times s divided by the square root of n is what we're going to be using. Alright, and so for number 1, we want to summarize what we're going to need to do a 99% confidence interval. I need x bar, I need s, I need n, and I'll need t, which I'll have to look up on my, well, either look it up on the table or use your calculator's inverse t function, which requires us to have the df, degrees of freedom, and then we'll look up the t. So those are the things we're going to need. These four from the formula, and df anticipating that I'm going to have to look up the t. Okay, x bar and s, those are your sample measures. Those are the two things you get related to raw data when you're trying to do a confidence interval for means. It's the sample mean, the average of all those IQ scores, and then the standard deviation of all those 15 IQ scores in that sample. So sample mean, sample standard deviation, we got to get from the raw data. So you want to do this manually, not manually, but using the function on your calculators. But so you're going to work with raw data, so you go into your list. This is where you have to produce these yourself. Some problems, they give them to you. They'll tell you the average of your sample was, let's say, 89.5, and the standard deviation of your sample was, let's say, 5.8, and then you work with those. In this situation, they give us raw data. So we have to go into our list, or whatever software you want. You can do StatCrunch too if you have it handy. But I went to my list, I put all that data, all 15 values into L1, just one big list. And then I'm going to hit Stat. I'm going to go over to the Calc menu, and then the first choice, 1var stats, will compute a bunch of statistics on that list of data. And I'll grab what I need, and what I need is x bar and s. Alright, so that's what I'm going to do right now. Quit back to the main screen, out of the list first. Stat, over to Calc 1var stats. Your list is L1, your frequency list blank. If you have the older version, just hit enter. And there we go. I got 89.4, so I got 89.4666667, and I'll round it off to, you can round it off wherever, but I'll go one decimal place, even though the scores were to whole numbers. I'll go to 89.5. If you have something different from me, it's a typo. We should say exactly the same thing on our screens. So, and I double checked mine, so double check yours if you get something different. 89.5 is going to round it to, and my S, I'm seeing, like here, 5.7677, much of other digits. Make sure you're not looking for sigma. It gives you sigma and S. The other way around. They give you S first. They put a little X there. We've done that before, but don't worry about that. That's your population standard deviation. So if this were population data, that would be the standard deviation of that population data. This is a sample of 5th graders, so S is for sample standard deviation. That's the one we want. We can tell that's the one we want because literally the formula says S, not sigma, so we're using S. Grab S, not sigma, and I'll round it off to the same places as whatever you did x bar, and I'll go to 5.8, one decimal place. But if you do it differently, that's fine. My N, you count up the number of data points, or you look on there because it tells me there were 15, but if not, there are 3 rows and 5 columns of numbers, and so that's 15 values in my data set. My DF is going to be N minus 1, so that's 14. I'm going to use that for my lookup for my T. The T I got to spend some time on, making sure I know what I'm looking up. It is based on the confidence level I said I would draw my t distribution differently from my normal, so let me do that. It was narrower and wider tails, but it's not important. I just want to make sure that we know. Even though it's similarly shaped to a normal distribution, it is not. The probabilities are tweaked a little bit different for everything. It is a t distribution with 14 degrees of freedom is what I'm looking at here. It's my t-axis. I have 0 in the center. All of that's not relevant to what I need. What I need is t alpha over 2 and negative t alpha over 2 to be used in that formula. And I want to find those such that it's got whatever confidence level in the middle, 99% this time. Okay, I've done it many times. I'm going to just kind of talk it through rather than write it out. I'm going to do 1 minus that and then divide it by 2. 1 minus 0.99 is 0.01. Divided by 2 is 1/2%, which is 0.005. And that is one of the nice values that does appear on your table. If you have the function on your calculator, you can use that and you won't need to rely on nice values, but it will be anyway. Anyway, I'm looking at my table over there. 005 is the far right column. 14. 2.977 is what I got. Okay, and that's it. I just got to assemble it for number 1 via this formula. 89.5 is my point estimate. That's my best guess for the average IQ of 5th graders. But I'm going to do a confidence interval 99% by using 2.977 times 5.8 divided by the square root of 15. I will compute my margin of error first, which is everything after the plus or minus. It's the point estimate plus or minus the margin of error. So my margin of error is what I get when I do 2.977 times 5.8 divided by square root of 15. And I got 4.46, but I'll round it up to 4.458. I'll just go 4.5 to be consistent with that. Yeah. Okay, and then I'm going to get 2 boundaries when I subtract from my lower bound, add from my upper bound, and then I will be 99% confident that the true average IQ of 5th graders is between those boundaries. And if you round it differently, your answer is going to be slightly different, but it's no big deal. I think I got 85.04 if I went extra decimal place, and 93.96 if I went 1 extra decimal place, but here I got 85.94, and that's sufficient. Came out nice round numbers by coincidence. Okay, so I'm 99% sure the true average of 5th graders is within there. Okay, let me... Okay. Number 2. Oh, that's my answer right there for number 1. Number 2, what's my margin of error for the 99% confidence interval? I just did it. 4.5. I talked about it. It's a margin of error. So whenever I ask you a follow-up question related to the margin of error on your confidence interval, you had computed it at some point, probably, depending how you do it. How much should I do? Oh, 4.5. I mean, units, it's pounds, if it's weight, inches or something. I guess you can call them IQ points. I don't really care, but points maybe. And then if the true average, let's see, if the true average is 92.5, is that within here? Right now it's a question mark. I'm not saying it is yet, but I believe it is because we got 85 there. My lower bound, I'm going to draw it out as this is my interval between there and there, and I just want to figure out where 92.5 is. If it's out here, then the average is higher than what we expected or what we predicted. We predict it's in here. If it's 95, it's higher. If it's 84, it's lower. Either in those cases, it would be no, our interval does not contain it, and we were wrong. But 92.5 is, let's say, right there. It is, yes. So it is contained in there, yes. So you can give a yes as your answer. All right. Next, we're just doing the same 70% confidence interval. They didn't give us a new data set, they didn't give us a new sample, so we're using the same thing. So I'm just going to erase what's going to be new. So first of all, change this to number 4, and then I will think about what I need to change. The data is the same. We're still working with the same sample. We're just going to get a different interval because we are going for a different level of confidence now, less confidence, 70%. 70% will be a narrower interval, so it'll be a narrower range for less confidence. That means this whole picture is going to be different. My breakdown of my percentages on my t-distribution. So my t is going to be different. Let me erase that. However, my sample, it's the same sample data. So my x bar and my s are going to be the same. It's still 15 data points, the same 15 data points. My degrees of freedom are still 14. So I just need to redo a t based on the new confidence level. Still t to 14 though. But now I had 99%, and if I want to, reflect the smaller confidence level, I'll move those in. I mean, it doesn't need to be an accurate picture, but the idea is now it's going to be further in with less probability in the middle and greater probability in the tails now. What probability is in that tails? Because I got to look it up, another t, a new t. 1 minus 70 is 30. 30% both tails combined divided by 2, and I get 15. 15 plus 15 is 30, plus the 70 is 100%. So 15 is what I'm looking up on my table with degrees of freedom 14, and it is one of the values on here, 1.076. That's my new t for my new 70% confidence interval. Alright, let me just repurpose all of this. My answers will be different. But I will be using, so x bar plus or minus t. I'm putting it in red because it's different from last time, but I'm highlighting what's changed and what's the same. Alright, sorry, one more time. X bar is the same, plus or minus a new t for 70% confidence times s, which is the same, divided by the square root of 15, which is the same. That's it. I'm redoing the same thing, but with a new t. And that means my margin of error is different. It's going to be smaller, because again, it went narrower, so it's a tinier, smaller margin of error. 1.076 times 5.8 divided by square root of 15. 1.6. Okay, and I'll do 89.5 minus 1.6. 87.9. And 89.5 plus 1.6. 91.1. All right. That's it for number 4. And I'm 70% confident. I was 99% confident that the true average was within that wider interval, and now it's a narrow interval. I'm less confident that it would be in here, and then less confident meaning I'm 70% confident that the true average IQ of 5th graders is between 87.9 and 91.9 IQ points. Number 5, that's number 4. Number 5, same questions as before, but for the 70% margin of error, 1.6 IQ points. And 6, does my true average 92.5, is it contained in there? Again, I'm not sure about that yet, but I'm going to write it in, and if it's not, I'm going to put a slash through it for not. And then I'll answer yes or no, depending if it is or not. And you can tell, I'm just making sure we can all visualize it. My boundaries are 87.9 is my lower boundary, 91.9 is my upper boundary. This is my confidence interval right here. Between there and there, I'm 70% sure. Whereas 92.5, it's above 91.9, is outside. It's not within my confidence interval. That's a no. It's not contained in, but if you just want to answer it in English, just a no. It does not contain it. That's it. Okay, that's it for 8.3 for practice, just some more practice problems, and then if you do your homework, and then we move on to chapter 9.